Good morning, grade 7. So we are learning some vocabulary words this week, and this is something that is best done not on a whiteboard. It's usually best done with PowerPoint. So keep your eyes on the presentation side of the screen. I pinned it there. It should be pretty obvious. We're going to run through some vocabulary words. Make sure that you log into the fun little computer games that I've loaded to help you learn these vocabulary words. They are important. You need to know them for the future. Okay. So we are introducing algebra. And algebra sounds scary, right? It's not, okay? You can relax. You've actually been doing this since grade 1, okay? We didn't call it algebra back then. So for example, you have 3 plus a little box equals 4. You used to do this in grade 1. And as a grade 1 student, you would go, oh, I know what that is. A 1 goes in that box because 3 plus 1 is 4, okay? This is, in fact, algebra. Okay, and in fact, we even have a word for this. Okay, we call this solving by inspection because you know that 3 plus 1 equals 4. When you see 3 plus blank equals 4, you know that a 1 fills in the box. Okay, as you got older, we made these problems a little bit more sophisticated and we started using letters instead of boxes. So now we would say 3 plus x equals 4, but it's still the same question. X is equal to 1. Okay, it's not really any harder. There are some things that we end up changing a little. We have some new vocabulary words. So for example, these letters that we use to represent missing numbers are called variables. Okay. We often use x as a variable. The reason for that is complicated. It has to do with the fact that you can graph what we call expressions. You can put them on a graph. And so we like to use x and y really, really often in these because there's the x coordinate and the y coordinate on a Cartesian plane, right? You can graph these things. So because we use x as a variable a lot, we try not to use x as a multiplication symbol when we're doing algebra because it's kind of confusing. So here we have 4x equals 16. Well, you might be able to figure out that what you mean is 4 times by x equals 16, but this is really very, very confusing when you get right down to it. So we don't do this anymore, okay? We are going to stop using the x as a multiplication symbol unless we actually have 2 numbers that we're multiplying. If there's a letter involved, we are going to instead squish those together. So we squish the variable together with the number. We use that to represent multiplication instead. And the example for this is 4x, which means 4 times x, whatever the value of x is, equals 16. And some of you are already probably shouting at your computer screen, x is 4, x is 4. Yeah, I know, it's okay, calm down. Okay. Remember, we already did a lot of this in our geometry units, right? Area is BH, base times height. Area of a triangle is BH divided by 2, base times height divided by 2. When we did area of circles, we said pi r squared. We didn't have to say pi times the radius times the radius. We've got shorthand for this now. It makes it quicker to write. It's a little bit easier on your hand as long as your brain remembers what it means. Okay, so this is going to be common from here on out, all the way through high school, straight through university. We're going to be doing this. Okay. So let's get on to those vocabulary words. We've already learned the first one. This looks like a horribly complicated expression, and it is about as complicated as they get at the grade 7 level. Don't worry, by the end of the month, you will have learned how to solve this and figure out what the value of x is. Okay, we'll get there. And now, of course, my brain is calculating it. Anyway, so in this case, the variable is x because that is the letter that they're choosing. And as I mentioned, x is easily the most common variable. Okay. Our next term is the numerical coefficient. Okay. So this is a number that multiplies the variable. Okay. So in this case, we have 4x. That means 4 multiplied by x. So this is our coefficient. Okay. Constant is a number that you are either adding or subtracting. The value of that number is not going to change, which is why we call it the constant. Okay. In this case, the constant is 7. Some people might tell you the constant is -7. That's fine. Okay. We're subtracting 7. It's the same effect. An operation is any math process, whether you're adding, subtracting, multiplying, or dividing. In this case, we have 2 operations. We have 4 times x, so we have multiplication, and we are subtracting the 7. So we also have subtraction. Okay, so we've got 2 operations going on in this particular equation. Okay, now we've got some slightly more complicated looking stuff on the board. It's okay, you don't have to solve this stuff, don't worry about it. So an expression is any single number or variable or a combination of them, but we don't know how much they're worth. So for example, this here 4n squared plus 7, we don't know how much n is worth. We haven't been told. It's not equal to anything yet. That's called an expression, okay? And some of you might be thinking, well, that's useless. Why would you give me something where I can't even figure out what n is worth? Actually, these can be useful, okay? So you can use these, for example, in formulas. Area equals base times height. Well, we don't know what the base is, we don't know what the height is, but we do know that we can use this formula to calculate the area of a parallelogram. Companies will use formulas to determine the price for a certain number of things. They program these into their till, right? So these are in fact useful, even though it might be frustrating because you don't know how much the variable is worth, okay? So that's an expression. It does not have an equal sign. We don't know the value of it. We don't know how much it's worth, okay? An equation, on the other hand, does have an equal sign. It has two parts that are equally balanced. They're perfectly equal to each other, okay? So this on the bottom is an equation. This on the top is an expression, okay? So some definitions here. An equation is a math statement with two expressions that have the same value. Some of them are really simple. 1 + 1 = 2. That's an equation. On the other hand, this one down here at the bottom, it's also an equation, but it's a complicated one. I don't even know exactly what this is for, by the way. I just found it and I was like, whoa, that's impressive. I have a feeling it has something to do with launching something out of a catapult, because pi is involved, so whatever it is, it's moving in a circle, and we've got velocity here, that means speed, and then theta here is usually used to calculate the angle of something on launch, so I think they're throwing something and it's launching in a curve, but I'm not at all certain. A physics professor might be able to tell you this, Ms. Lowy might be able to tell you what this means, okay? So an equation always contains an equal sign. It always has two equal pieces, okay? And one more term. Opposite operations are operations that are the reverse of another operation. They oppose each other. They verse each other, okay? So there's two different pairs here. The first pair is addition and subtraction, okay? So addition and subtraction are opposite operations. If you add 4 and then you subtract 4, nothing changed. Okay, and this is useful later on in algebra when we start solving equations. We'll be using opposite operations. The other pair of opposite operations, you've probably already guessed this, are multiplication and division. Okay, so multiplication and division, again, if you multiply by 4 and then you divide by 4, you're left with the same number you started with. Okay, so those are opposite operations. Now make sure you log into that computer site and do the fun activities that I have for you that are using these vocabulary words so that you can learn them. And I'll see you in the next tutorial video. Bye.